Welcome to Flip Math Lesson 6.9, Symmetry. The key concepts there are to identify equal parts of shapes, to draw lines of symmetry to connect points, to draw missing parts of symmetric figures, and to locate lines of symmetry in two-dimensional shapes. The objective is to review symmetry, something you learned in first and second grade, and to provide opportunities to explore properties of symmetric shapes. Here you can see some examples of our two-dimensional polygons. You can see that squares, rhombuses, triangles, rectangles, even this arrow, this 1, 2, 3, 4, 5, 6-sided shape, seven-sided shape has a line of symmetry. As you can see here, this parallelogram, even though these sides are parallel, opposite lines are parallel, this one does not have a line of symmetry. It does not cut in half. Trapezoid has one. Each of our shapes has lines of symmetry. Some have more than one, some only have one. Let's look here. Words to know. Symmetry. When shapes can be folded, two halves matching points. So when shapes can be folded and two halves match all their points. So if I folded this butterfly, if I cut it from north to south, if I cut it in half and folded it together, the wings would meet at all points. If I cut the A in half north to south, the points of the A would match if I folded it together. Much like a piece of paper when you're making a snowflake. When you fold it together, they have matching points. That is symmetry. Those shapes are symmetrical because they have a line of symmetry. A tool that we'll use in class is a mirror, and I would like to use this in class with you instead of using it on the video. So you will see this mirror. It will take one side, as you can see, here's the lines here, and it will mirror it to the other side so you can actually see the lines over there. Those two lines are not actually there if you move the mirror, but because the mirror is there, it projects, much like a mirror, it reflects the line from the other side of the mirror. It works with two-dimensional shapes, so we can make symmetrical shapes using this mirror tool. Finding lines of symmetry. Here we have a square, rectangle, equilateral triangle, and a hexagon. So looking at first the square, if I go north to south, cutting it right down the middle, I have one line of symmetry. If I cut diagonally here, I also could fold this end to touch this end. That would work. I can cut it this way as well. This point here and this point would meet, as would cutting it here. So this one has 1, 2, 3, 4. This square has 4 sides. It has 4 lines of symmetry. The rectangle, you can cut across, you can cut up and down, but you cannot cut diagonally because this point would not fold into this point. The points would be on opposite sides, so this does not have more than 2 lines of symmetry. The equilateral triangle, you can cut north to south. So basically you're cutting just the points because it's equilateral. All the sides are the same. This has 3 lines of symmetry, 1, 2, and 3. And finally, the hexagon has 1. Notice how the opposite points are meeting, 2, 3, and 4. I'm going to move that line just a little bit over so you can see it there. And finally, a line going across here. If I do the line a little better, here we go, because you can fold it having this point meet that point. And finally, going across here. So you actually have 6 lines of symmetry on a 6-sided regular polygon. If it's a regular polygon and it's even numbered, you will have that many lines of symmetry. So a square is 4-sided, it's all equal. You had 4. Equilateral triangle had 3 sides, you have 3 lines of symmetry. And a 6-sided shape that's regular, because it's even numbers, had 6 lines of symmetry. Finally, creating a symmetrical shape. Here we have 1/2 of a letter. It goes up and then down. We want to create the same on this side to mirror. So if we folded it together, I would be connecting. So starting from here, I would go up and then I would go down. I have created the letter M. If I were to fold this side into this side, the points would match and it would be 1/2 of a letter M. Here is your line of symmetry cutting it in half. I can't go east to west because those lines of symmetry would not match. So let's take a look. I have a heart cut down north to south, a star north to south, a trapezoid north to south, and a check mark. If I were to fold these objects, which one of them does not have a symmetrical line of symmetry? Which one cannot be cut in half equally so that both sides are the same? The heart, the star, the trapezoid, or the check mark? Best of luck to you. Thank you.